Hello and welcome to another Algebra 1 video by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 6, Lesson 5 on zero and negative exponents. Alright, so let's get right into them because these things are a bit strange and they take a bit to get used to, and this probably isn't even the first time you've seen them, right? So positive whole number exponents represent repeated multiplication by the same number. We've been kind of playing around with those for a long time. Right? In theory, you've actually seen positive whole number exponents since about fourth grade, right? But we want to be able to extend this idea so we can understand and use both zero and negative exponents, all right? So let's jump into exercise number 1 to really try to understand, right? Exercise number 1. We can think of powers of 2 as representing multiplication of the number 1 repeatedly by 2. Now, let's talk about that a little bit, right? Because most of the time when people see something like, let's say, 2 to the third, they think of that as 2 times 2 times 2. That's fine. That's equal to 8. But really, at its essence, right, 2 to the third is actually 2 times 1 times 2 times 2. Or it's better yet, 1 times 2 times 2 times 2. We kind of want to think about the number 2, strangely enough, as being 1 times 2, okay? Now, letter A, let's take a look at this. Fill in the pattern for powers that are not negative. What does this lead you to fill in for 2 to the 0? All right, so in other words, right, I claim that we want to think about 2 to the first as 1 times 2, which is 2. 2 to the second as 1 times 2 times 2, which is 4. 2 to the third, right, I can think of as 1 times 2 times 2 times 2, which is 8. 2 to the fourth, 1 times 2 times 2 times 2 times 2, which is 16. But then just take a look at this pattern, right? If 2 to the first means multiplying 1 by 2 one time, 2 to the second means multiplying 1 by 2 twice, 2 to the third means multiplying 1 by 2 three times, then 2 to the 0 means multiplying 1 by 2 no time at all, right? I literally want to think about a number raised to an exponent as representing how many times I'm going to multiply the number 1 by that number. And so 2 to the 0 is equal to 1. Now, that's weird enough. Now let's talk about negative exponents, letter B. If positive exponents indicate multiplying the number 1 by 2 repeatedly, then negative exponents should indicate dividing. All right? So in other words, 2 to the minus 1 is the same as 1 divided by 2. Not just the same as, it literally means take the number 1 and divide it by 2 once. On the other hand, 2 to the minus 2 will mean take 1 and divide it by 2 twice. Now what that really means is divide it by 1 divided by 2 times 2, which is 1 divided by 2 squared, which is 1/4. 2 to the minus 3, on the other hand, will then mean 1 divided by 2 times 2 times 2, which is 1 divided by 2 to the third, which is 1/8. Let me extend this a little bit. And 2 to the minus 4 is 1 divided by 2 times 2 times 2 times 2, or 1 divided by 2 to the fourth, or 1/16. If I always kind of think about it as what I'm doing to the number 1, then it's kind of easy to understand both zero and negative exponents. In fact, we can now formally define them, zero and negative exponents, right? Let's take a look. Zero exponents. B to the 0 equals 1 as long as the base isn't equal to 0. So we're never going to have a base equal to 0. Basically, what we're saying here is any quantity other than 0 raised to the 0 power is equal to 1. Because again, 3 to the 0, 5 to the 0, 1/2 to the 0, any of those are basically saying, what do I get when I multiply 1 by b no times at all? So if I have the number 1 and I don't multiply it by b at all, what do I get? Oh, I get the number 1. You know, if I have 256 to the 0, what that means is take the number 1 and multiply it by 256 no times at all. Oh, I'm going to still have the number 1 because I didn't do anything to it. All right? Weird, but true. Now negative exponents on the other hand, right? B to the negative n is just saying, look, I'm going to take 1 and I'm going to divide it by b to the n, okay? They represent dividing the number 1 by b to the n. Okay, so let's take a look at this real quickly, especially with the negative exponents. And let's be clear, you work with negative exponents far more than an exponent of 0. An exponent of 0 is really kind of just like, oh, okay, it's there. And it's important, don't get me wrong. But the negative exponent's way more important. Let's take a look at exercise number 2. Which of the following is not equivalent to 5 raised to the negative 2? All right. Well, again, let's just kind of talk about it, right? 5 to the minus 2 literally means take the number 1 and divide it by 5 squared, right? So that's equivalent to it. And of course, 5 squared is 25, so that's equivalent to it. Now, I might need to say to myself, well, what is 1 divided by 25? But I could always do that on my calculator and get 1 over 25. But that is 0.04. So that's also equivalent. What it's not equivalent to is 1/10. Now, obviously, by the way, let me just clear this out really quick. Obviously, your calculator can handle negative exponents, right? I could do 5 raised to the negative 2 on my calculator, and it gives me 1/25, right? So obviously, your calculator is pretty good at math. It has no problem evaluating negative exponents. It also would have no problem with what 5 to the 0 is. Hey, look, it's equal to 1. All right, now watch out. The last thing you ever want to do right now is go, well, if the calculator can do it for me, I don't have to understand any of this. All right, that's never a good attitude to take on. Let's take a look at exercise number 3. Little function notation. If f of x equals 3 times x to the minus 2 plus 2 times x to the 0, then which of the following is the value of f of 2? Show the work that leads to your answer. Remember, exponents always come before multiplication. All right, so what I would like you to do is go for it. You know how to do function notation. You're going to take that 2, you're going to plug it in wherever there's an x in that function definition, and you're just going to evaluate the output. Pause the video now and see if you can figure out what the answer is, and try to do this without using your calculator. All right, let's go through it. So what I've got is I've got f of x equals 3 times x to the minus 2 plus 2 times x to the 0. All right, so f of 2 is going to be 3 times 2 to the minus 2 plus 2 times 2 to the 0. Now, 3 times 2 to the minus 2 is the same as 3 divided by 2 squared. And 2 to the 0, remember exponents first, is going to be the same as 2 times 1, right? 2 to the 0 is equal to 1. So, give myself a little more room here. F of 2 is going to be 3 divided by 4, right? 2 squared is 4, plus 2, and that's 2 3/4. Choice 1, right? Again, let's review here, right? We've got 3 times 2 to the minus 2. We could have made the 2 to the minus 2 right away into 1 over 2 squared, which would be 1/4. And then we could do 3 times 1/4 and get 3/4. But I really like to look at 3 times 2 to the minus 2 as I am taking 3 and I'm going to divide it by 2 squared, right? Likewise, 2 times 2 to the 0, right? 2 to the 0 comes first. That's equal to 1. Then I get to multiply by this 2, and I end up getting 3/4 plus 2, which is 2 3/4. That's just what that's equal to. All right. Now, because we now have negative exponents, we can formally develop the third exponent property or rule. Now, I'd like to recall the first two. So let's come in on the board now. Right, my first property, x to the a times x to the b is equal to x to the a plus b. When I multiply two things that have the same base, I add their exponent. The second property is x to the a all raised to the b equals x to the a times b. In other words, if I have something raised to an exponent, then raised to another exponent, I multiply the two exponents together. But now we want to develop the third exponent law. All right, exercise number 4. Rewrite each of the following expressions in simplest exponential form. Okay, now we got work on simplifying fractions involving exponents last time, in the last lesson. So what I'd like you to do is pause the video now and simplify each one of these things to see what you get so that we can then develop the third exponent law. All right, well, real quick, right? We have x to the fifth divided by x to the second. Remember how we did this in the last lesson, right? I had x to the second divided by x to the third all over x to the second. Those two canceled, and I got x to the third. 3 to the 10th divided by 3 to the 5th would be 3 to the 5th times 3 to the 5th, all divided by 3 to the 5th. There's a lot of 3 to the 5th there. Those cancel, and I get 3 to the 5th. Right? X to the 8th divided by x to the second is x to the second times x to the 6th, all over x to the second. Those cancel, and I get x to the 6th. Right? So what seems to be going on here? Right? It appears that when I have x to the a divided by x to the b, right, I just get x to the a minus b. And that is, in fact, the third exponent law. X to the a divided by x to the b is equal to x to the a minus b. Now you might ask yourself, what in the world does this have to do, right, with negative exponents or a zero exponent? Well, let's take a look and see how that plays out in the next problem, right? So x to the a divided by x to the b is x to the a minus b. Even though this exponent law was developed when the exponent of the numerator was larger than the exponent of the denominator, we can still see that it holds when this isn't true. In other words, when the power up here is smaller than the power down here. So let's play around with that in exercise number 5. Rewrite each of the following expressions two ways. One, by using the exponent rule developed in exercise 4D, and two, by simplifying using techniques we've seen in the last lesson. All right, so, the first one's almost silly, right? The first one is 2 to the 4th divided by 2 to the 4th. Well, remember, we just had that exponent law that said, hey, if the bases are the same, that's going to be 2 to the 4 minus 4, which is 2 to the 0. All right? But we also have this idea that any number divided by itself is equal to 1. Now, if two things are equal to the same thing, right? 2 to the 0 is equal to 2 to the 4th divided by 2 to the 4th, and 1 is equal to 2 to the 4th divided by 2 to the 4th, then that means that 2 to the 0 must be equal to 1, right? So that fits with what we know about zero exponents. In other words, that exponent property that said when you divide two things that have the same base, you subtract their exponents works awesome when the exponents are equal to each other. But now let's look at two cases where the exponent in the numerator is literally smaller than the one in the denominator. Let's take a look at letter B. Right? Here we've got x to the second over x to the 7th. Right? Now the exponent property is always the power of the numerator minus the power of the denominator. So just using that, remember 2 minus 7 would be x to the minus 5. So just using the exponent property, right, I'd get x to the 2 minus 7, which would be x to the minus 5th. On the other hand, if I use my simplifying techniques from my last lesson, I could rewrite this fraction as x squared times 1 over x squared times x to the 5th. That x squared and that x squared would cancel, and I'd get 1 over x to the 5th. Right? And those two are equal to each other. Right? Negative exponents indicate division of the number 1 by the same base raised to the positive power. Right? X to the negative 5 and 1 over x to the 5th. And we'll see exactly the same thing with letter C, except here our base is numerical, right? If I used my exponent property here, 5 to the 6 minus 10, I'd get 5 to the minus 4. Okay, that's just using my exponent property. On the other hand, using my simplification techniques from our last lesson, I could rewrite this as 5 to the 6th times 1 over 5 to the 6th times 5 to the 4th. Those 5 to the 6th would cancel, and I'd be left with 1 over 5 to the 4th. Okay. Now, you might be saying, well, what is the purpose of all of this? The purpose of all of this, right, is to show that this exponent law, right, is consistent with what we just learned about zero exponents and negative exponents. On top of that, it gives us a very easy way to simplify any fraction where the numerator and the denominator have the same base, right, but they've also got exponents. You simply retain the base and you subtract the exponent in the denominator from the exponent in the numerator. Always in that order. Always, always, always. Now, sometimes that'll give you a positive exponent, in which case it's just, like x to the third. In other cases, it might give you a negative exponent like x to the minus 2, right? All of that, very, very important to kind of understand. Now, let's finish this up with one more problem. All right, that is just not it. I wanted to go to the next page. There it is. All right. Now, we're going to work more with all the exponent properties. I mean, quite a bit. For now, we mostly want to feel comfortable with positive exponents representing multiplication, negative exponents representing division, and I guess a zero exponent with representing leave the thing alone, right? That's kind of like a zero exponent means, hey, I mean, don't multiply by anything at all. And let's see all of those come together in exercise number 6. Consider the exponential function f of x equals 16 times 2 to the x. Find each of the following without your calculator. All right, well, let's do this together, right? This is just function notation. I've got this beautiful function, 16 times 2 to the x, and if I wanted f of 0, that would be 16 times 2 to the 0. Now remember, right, order of operations, right? Really, what we're saying here is take the number 16 and don't multiply it by 2 at all. Just don't. What do you get? You get 16. Or, if you really want, right, 2 to the 0 is equal to 1, so f of 0 is just equal to 16. Okay, so there's our zero exponent. Let's go with a positive exponent, f of 2. This is kind of what we already are comfortable with. F of 2 is going to be 16 times 2 to the second, right? We evaluate that exponent first. 2 to the second is equal to 4. And 16 times 4 is equal to 64, right? So here we've taken 16 and we haven't done anything to it, right? Here we've taken 16 and we've multiplied by 2 twice and gotten 64. And now let's take a look at a negative exponent. F of negative 2 is going to be 16 times 2 to the negative 2. And again, what that really is indicating is we're doing 16 divided by 2 squared. That's 16 divided by 4, and that's 4, right? So in the case of the zero exponent, I leave 16 alone. In the case of a positive exponent, I'm multiplying 16 by 2 twice. And in the case of a negative exponent, I'm dividing 16 by 2 twice. And think about that, right? That's really the case. 16 divided by 2 once is 8. Divide by 2 again, and we get 4. All right? Positive exponents represent repeated multiplication. Zero exponent means multiplying by 1, which doesn't do anything. And negative exponents indicate division by that base. Okay. Now, as you move on in math, right, you originally learn about just positive whole number exponents. Then by, like 7th and 8th grade, you start dealing with these negative exponents and zero exponents, which are going to become more important in this course as we go on. When you hit Algebra 2, you'll play around a little bit with fractional exponents, which is really quite cool. All right, no worries about those here, and I don't even advise thinking about them right now because they're pretty deep, all right? But it's important as you go along to make sure that exponent properties are consistent with what you understand about these, and also that they make sense in terms of both multiplication and division. All right, no worries, we're going to get a lot more work with this as we go on in this course. For now, I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking. and keep solving problems.